Hello, hello, hello. All right. Um, I was planning to do or show you something with. Sorry, I started hearing myself, so that was awkward. So I was going to share something to do with LLM, ChatGPT, AI, whatever is um, very hot right now in the market, um, which is really interesting as well. The way AI and machine learning has developed in just a couple of years. Not that they just developed in a couple of years, but it was long in making, and suddenly it has kind of changed everything. I have been looking at these um, APIs like OpenAPI from uh, sorry, ChatGPT API from OpenAI, uh, and few others like pre-trained models from some developer and all that, which is quite cool. So because I have been doing these uh, lazy Sunday live building a game, I would want to continue with that. Um, so we have these players, and at the same time, I think because I'm also um, involved with like researching on this AI stuff, I wanted to just, you know, because this live stream has no viewers basically. Nobody watches my live shows. However, I enjoy making this thing. It's always like really, I feel kind of lonely. So what I was thinking was if I do something really happening in the market, maybe people will join. Maybe there will be some participations and all that. So I was just thinking of doing that, but very uh what was I gonna say? I was too occupied by these. Yeah, I wanted to do like at least something with this. Like we have like these characters working. We have collision detections, platforms, everything in place. We could actually add something to this and make this actually a playable game. So that's also one thing I wouldn't just want to give up on. But still I don't see any viewers, so anyway. Whoa! Okay. So right now I'm using both my hands. My left hand is controlling the blue balloon and my right hand is controlling the red balloon. So if we want to continue with this development, the next thing would be collision detection between the players. So player hit each other, they should bounce away. How do we do that? We have done that several times, like when we bounce on the walls, on the left, on the right, on the top, when we bounce on these platform walls, on the top, on the bottom, on the right, on the left, sorry, not on the top. You don't bounce when you land on a platform. So to apply the same for these users should not be very difficult, right? So what can we do? So first of all, let's think what can be an issue here. What might we face? One thing is both the players will be moving mostly. So far what we have done is one of the object is stationary, like the walls and the platforms. They're stationary and only the player was moving in that case. But for our new case, both the objects will be moving. And also how hard they hit each other depends on the speed of both the players, which means it's not always like for wall cases we only considered player's own velocity on x-axis, but in this case we need to consider velocities of both. Nuts. I'm not hungry, I'm just eating. So let's say if a player, if one of the players is moving at a velocity of say 5 and the other one on the right is moving at speed of 10, so one is moving half the speed, what would be the result? It also depends on the weights, the mass of two players, but considering both are equal, both are the same weight, that would simplify the maths a little bit. But does the speed really, I don't know what happens if two bodies with same weight come at each other, but one at some speed and one at twice the speed, they hit each other. Now what would be the resulting rebound effect? I would say both will just get half of like rebounding force. Um, like they equally bounce back. Does that sound correct? I think because both have same masses, I don't think there is one winner who like pushes other and stays or hmm. It's a very deep problem. So for now, assuming that they both just bounce back in equal force with equal force, mm, that means they will probably what we can do is we can add up both velocities combined. Hmm. Hmm. No, I think that's fine because even if one was just floating on the air and the other one come and strikes it, this guy will go a bit forward, this guy will come back, but I don't think they will have any difference in velocity. Let's assume that's the physics, that's how nature works. What do we do next? Mm, since we have like this bounding area for each player now, mm, it's pretty similar how we would mm, do the collision detection on those players. Mm. So for each player, ah, so for each platform, we said, is any player hitting the platform? Mm, and for each players, we're checking if player is on some platform. Okay. So now, just like platforms, we will also do collision detection for players. For players, for each P, sorry, what did I do? Oops, what did I do? I don't know, what did I do? I deleted a bracket? No, what? My language changed. How did I change my language? What did I press? Oh my gosh. Okay. Okay, now I deleted a bracket here. So each player on each player Interesting. So here we have no. Where are we doing the bounce when the user is bouncing on the wall or the view screen, viewport? That's an interesting question. Where did we do that? So this is going down. Oh, maybe I just put the thing into some function like one up here. Player, yeah, update position. So when player's position is being updated, we are checking if it's hitting something. So now, if we say should we just add it to here? But we need to check. Hmm. Hmm. This is an interesting problem. So if we want to check if two players or any number of players are hitting each other, colliding with each other, we could do kind of search for that, like we get the list of players, and find if players are near to each other. So if we just we still have this 0 viewers. I'll eat some chocolate now. What happened? Ah. So let's just do this. For each player, for each, we're just going through players from each player one. Like player one, check collision player two. So if we do this, we'll go through each player and then we will check. Yeah, here we need a condition. If pl dot name is not, did we call it player dot pl dot name? Did we call that? What's happening here? I need a curly braces here. If player 1's name is not equal, the two players we are comparing is not the same player, then check the player's collision. Right? But wait, then we are comparing this. We'll be comparing same player, same two players twice, because one way we will be doing player 1 and player 2, and then player 2 and player 1. This doesn't sound really efficient anyway. I would just, I would just say globally check player collisions, and this will just take all the players and then map them and then see if their coordinates are overlapping. I think that will be very efficient. So check player collisions. This should give yeah, not just check, but do handle player collision or something like that. I don't want to do anything more than that. Handle players collisions. What does it do? It will simply, I'll just start writing the function here. Check collision now. Handle, and doesn't require any parameters. Do we have object or array of players? Doesn't seem like so. Here. We do have players, so we could actually clean these up. Right? So I could say players dot for each p dot draw. Not just draw, I could also say p dot, what was it, update position, and that would do the same thing as these. not exactly same. Actually, that one was doing in different orders. Right now, we're doing player 1 update draw, player 2 update draw. But before we were doing player 2 update, player 1 update, player 3 update, and then player 1 draw, player 2. But don't, oops, don't think that is going to make any difference, right? It doesn't look like it's making any difference. Okay. Now, where were we? Here. We have this function that is this wire is annoying wire. Whenever I see this 0 viewers, I get really frustrated. Okay, handle player collisions. If I have players, players, what was I going to do? I can take all the X and all the Y's and then sort them, sort X and sort Y, and then find only those that are less than whatever width our player has. I don't remember. Yeah, 20. No. Sorry. Yeah, 20. Let's check our file. How can you tell the size of the file? Ah, 20. Yeah, 20 times 32. So we have our players with width 20 pixels. So 20 pixels. What happened again? And so what I will do is I think this still is a bit going to be a bit too much. Anyway, did I forget how to write for loop? I is less than players dot length I plus plus. For this many times, what I want to do is X axis, I don't know how to name this, axis is I would just use players index and x, yeah. So this should be an empty array. Then I will xs dot push. So I am just trying to avoid creating a lot of loops. So I will try to just, yeah, it sometimes, yeah, you want, also you don't want to early optimize, but I just somehow feel that this is going to be a bit of, why did you add one here? Oh, what am I doing? I had x, y. So I have now x's and y's. Huh. Now I think, again, now I think going through each player would be probably the best way. Like, if I do this, then I'll have to again find which, like, if I now found out, like, I sorted it and I found out two of those axes are close to each other or they're colliding, I also need y for that exact player, and I have no way to find that. Not no way, but still there's a work there. So damn it. Okay, I'll just do every player then. Right, because we could actually track if this pair of players is already being evaluated and they are handled, and we can skip the repetition simply. I don't know why am I overthinking here. Okay, anyway, so let's do the same, whatever I try to do in the first place. Players for each P1. Did I do this? Yeah. No. Here I will again say players dot for each PL dot check collision P1. Oh, what did I do? PL P1 P2 P2 check collision P1. So this way, what happened for each, I didn't close this, no, for each this one is not closed either. Are you kidding me now? No, this is a function, right? So here, this needs closing. Now, there's collision detection. We still need to do this. So what we did, P1. One, but we forgot to check if P1 is P1.name is not equals wow, not equals P2.name. Only if this, then we want to do the wow. Right. If P1.name is not if they're different, then what the hell? Am I stupid or what? What the? What is missing here? If this am I blind or what? Okay, now this one is from the inside there. Now for okay. Okay, now if they're different, then do the collision. P2 check with P1. Play one. We could now define this method where player here check collision. Oh gosh. I think I should just start typing every symbol. Check collision. No, what? Yes. We get another player, other player, and here. For now, I would just log this dot name and oh come on, name and other player dot name. What? This and other symbol. Oh, now I remember it's how hard it is to check console here. Oops, no. This one. This other. So yeah, it's doing that. It's doing the check for us. So yeah, it's doing the check, which looks good. Now, actually, I could do something like this dot x. No, actually, if this dot x is this dot x minus, because it's never going to be minus, so x y values are always positive, so we can just simply do this dot x and other player dot x, right, is, and we want to make this absolute difference of their x position is less than, so their x position is actually on the left, right? So if their x position is less than 20, less than 20, then we have a collision, right? So just doing that, we will now only see the logs if their x position collide. Let's check that. Here, C6. No, what's being logged here? There you go. So because they are colliding in x-axis, it's logging those. But if I move here, it's not. Right? If I move into their x. So just to make it simpler, I will just fly this guy here. See? If I don't collide, you see that number. But if I suddenly collide, there is this explosion of logs. Boom! Right? So that's how we check collision. And that's not enough. There right now only we are comparing that, checking that on just one axis. What we want is, we want and yeah, if we want to also check their y positions, we want to do that for 32 pixels. Now it's going to be even cleaner than before, because now we will see these guys. When see, it used to log those collision stars when they were close to each other. Now if I fly over this guy, it doesn't show me that, oops, actually it touched. So if I just fly over it, it won't show the log. But if I touch it, there you go, explosion. So now we have the condition where the players are colliding. Now what we want to do is wait, I actually could do to avoid duplicating this check. I mean, not this, but this. What I could do is I could not do for each, but what I can do is I could also use index here, idx, and instead of for each here, I could do for here. For I is, we'll let I equals index, and I is less than players dot length minus, so whatever we offset on the left, so we are only starting from the index of the parent, right? No, even index plus 1 actually. So we don't even want to start from index, but we want to start from index plus 1. Yeah, I could really use a drawing paper. So if I start from the next guy, so there's guy, player. Same 3 players, we were trying to do the whole thing again, but what I'm trying to do is 3 guys. Now we start by first guy, we skip the first guy because first guy is himself. We have the second guy, compare, are they colliding? No? Okay, let's move on to next guy, compare, no. Okay, now we move on to second guy on top, and we're skipping the second guy and we're taking the third guy here. Then we are comparing these two because they were never compared, and then say they didn't collide, then move on to the next guy, but then there's nobody else, so nobody else to compare, so every one of them is compared to every other of them. That's how you do it. So now I need to also check if I actually exceeded, like if this is not the last player, right? If I don't know, if not, if x not equals, if idx, that's correct. So if index is not the last one, then we have this loop, and then we have p2 is something we need to define. I always miss something. Okay, here, let's complete this. So players dot length minus 1. No. So if we are starting from index plus 1, we will have to do players length minus index, right? Sorry. So what this will do is, say we are at index 0, it will not skip. Okay, well, yeah, that's right. See, if we start, say we have 3 players and we start from 0, and we have idx 0, so the I will start with 1, and it will only go until length minus 1, length minus 0. minus 1. Yeah. Right, so if we are now at the second layer, and that is index 1, the I will start from I plus 1. 1 plus 1. Index will be 2. No, I will be 2. Index will be still 1. Then player is okay, I is 2. And then it will, now I is 2. This is 2 minus idx is 1 minus 1. 2 minus 1 is 0. Oh, no, player's length is 3 still. 3 minus 1 is 1. If I is less than 1, which... Oh gosh, this is so confusing. So, really I need to draw. So this is what it is doing, is it's just skipping the last one, right? If the index is, say, less than, oops, what did I do? Less than player's length minus 1. So that means only if it's less than the last player. So if it's the last player, it will just skip this. And for index, we start from index plus 1, which is fine, and it will go until so let's say third, 3 people, second index, which is 1. 1 plus 1, 2. There. And I is less than player dot length is 3 minus